In this video, we're going to take a couple limits of a piecewise function. This is g of x equals cosine of x for x is less than 0, 1 minus x for 0 is less than or equal to x is less than or equal to 2, and x squared minus x minus 2 over x minus 2 when x is greater than 2. So, first we're interested in the limit of as x approaches 0 of g of x. Now, 0 is right in the middle of two of these different piecewise components. So what that tells me is that in order to take this two-sided limit, whenever we don't have a plus or minus, it's asking about from both sides, we need to first find the limit as x approaches 0 from the negative direction and the limit as x approaches 0 from the positive direction. So, if we find those and we get the same thing, that tells us that the limit exists and is that value we get. If we get different things, that means the limit doesn't exist. So let's take a look at the limit as x approaches 0 from the negative direction. Well, let's look which of these parts talks about values just a little bit less than 0. And that's going to be the top part, because that's for all values x is less than 0. So this is going to be the limit as x approaches 0 from the negative direction of cosine of x. And here's the thing. We don't know if g of x is continuous. In fact, g of x might not be continuous. These piecewise functions are very often not continuous functions. But what we do know is that cosine of x is continuous. And since we're just looking at that one piece, we're just looking at cosine of x, I don't really care about what happens for the rest of g of x right now. I'm just taking this one-sided limit, and that one-sided limit only cares about cosine of x. So I can evaluate this limit just by plugging in 0 to cosine of x. This is going to be cosine of 0, which equals 1. And we can do the same thing to approach from the positive direction. We're going to look which of these pieces talks about positive values that are a little bit bigger than 0. Well, the bottom two pieces both talk about values bigger than 0, but this one only talks about values that are also greater than 2. It's this middle piece that's going to talk about values that are just a tiny bit bigger than 0. So that's what I'm going to want to use to calculate the right-sided limit. 1 minus x. Again, g of x may not be continuous, but this piece of it is. This piece, 1 minus x, which is all we care about as we approach 0 from the positive direction, that is continuous. So I can evaluate this limit just by plugging in 0. So that will be 1 minus 0 equals 1. And what we see is, hey, our two one-sided limits ended up being the same thing. That means since the limit as x approaches 0 from the negative direction of g of x equals the limit as x approaches 0 from the positive direction of g of x equals 1. That means the limit as x approaches 0 just of g of x also equals 1. So we calculated that. It turns out in this case, if you factor in the fact that g of 0 is also 1, it actually ends up that g of x is continuous at 0. But we weren't really talking about that. We won't talk about that, super soon. So there we go. We did that limit. Now let's go ahead and take a look at the limit as x approaches 2 from the positive direction of g of x. Well, that is just going to be, what part of the piecewise function are we going to look at? Well, the values bigger than 2 are contained in this right side piece. So that's going to be the limit as x approaches 2 from the positive direction of x squared minus x minus 2 all over x minus 2. Now, you might notice this is not continuous at 2 because when you plug in 2, you're going to get 0 over 0. But the good news is we do know how to take limits like this. We're going to do the same tricks we did before. We're going to go ahead and factor. So the numerator is going to factor as x minus 2 times x plus 1. The denominator is just going to stay x minus 2. We see we get to do some cancellation. Remember, there's an invisible 1 right there. So this is really the limit as x approaches 2 from the positive direction, just x plus 1. And that is continuous at 2. So we can just plug in 2 for x and get 3. So that's how we would do that. As a quick aside, even though we didn't ask this question, if you look as x approaches 2 from the negative direction of g of x, well, now we're going to be using that middle part because that's for the values less than 2. That's going to end up being negative 1 because we just plug in 2 for x. And we actually see that the limit as x approaches 2, generally, the two-sided limit, does not exist. So that would be a case where the limit doesn't exist because we got two different one-sided limits. Not the same. So hopefully that gives you a little bit more information about how to take limits with piecewise functions.